Hi all, welcome to the course. Here we are going to see the OpenAI's Whisper. This is the GitHub repository where you can get the documentation and the code. So let's get into that. Here is a summary of this repository. Let me explain you step by step. Whisper's core functionality. Whisper is described as a general purpose speech recognition model. It is a multitasking model capable of performing multilingual speech recognition, speech translation, even spoken language identification, voice activity detection, and many more. This is achieved through transformer sequence. So Google introduced transformers. So there we have encoders, decoders. So using the same, the transformer sequence to sequence model trained on it is a huge audio it is trained like various speech processing tasks which is having high number of tokens. Special tokens are used for task specifiers and classification targets. And the approach of the training is like Whisper approach involves in training of massive data set, which is mentioned as 680,000 hours of publicly available audio paired with transcription from the internet, including 117,000 hours converting 96 languages and 125,000 hours of X to English translation. So this is a large scale and diversity contribution to its robustness. It achieves zero shot transfers capabilities. That is, we don't want to train it or we don't want to it don't want to see the data there. It can directly uh, predict the thing like it is zero shot. So the available models are six model sizes are available with four with English only version offering different speed and accuracy traits of this includes tiny, base, small, medium, large, and the Optimus Turbo model which I mentioned earlier. It is having many more things. It is having its community and it is having its own resources in the community. So let's go into the core architectural approach, how it is done. Input processing. So first of all the audio is resampled to 16,000 hertz. It is having a limit of 16,000 hertz, so it is getting changed there. And 80 channel log magnitude Mel spectrogram is computed from the audio, acting as a visual fingerprint of the sound. This is done on 25 millisecond window with a stride of 10 milliseconds. So what is this Mel spectrogram is like? It is used to remove the extra noises that is surrounding a Mel spectrogram is nothing but it has a upper bound and it has a lower bound. Within the fixed bound, the full waves will be traveling. So that is where it will be having the threshold. So between that, the process will be done. The encoder, that is the listener. The encoder is the first part of transformer model. So encoder, it always encodes, the name itself says. It processes the Mel spectrogram into the stem composed to two convolutional layers with filter with 3 and GELU activation, the GELU we used to say. The second convolution layer has stride of 2. So it is having two layers. So it has a special position of embedding that are added to the output as followed by the application of transformer encoder blocks. So you can see there. There is a transformer encoder block. These blocks are utilized. So the pre-activation residual blocks are known as the transformer encoder blocks. A final layer of normalization is applied to the encoder output. So the normalization includes a various technique where the data could be scaled there, it could be normalized there. The encoder and decoder share the same width and the number of the transformer blockers. So the decoder is the writer here. This API converts the speech into text. The decoder takes the process information from the encoder and generates the corresponding text. As I said, it is going to give you a text. It functions as audio conditional language model. It is used to learn position embedding and tied input output token representations. So this is how the architecture is designed, and this is trained over 680,000 hours. So we have the setup documentation which we have done earlier. So if you want, you can go to this repository and see the benchmarkings even. So we have various benchmarkings, how to use in the command line. So we have various usages here. So it gives you a good interaction. Like you can have your more ideas on this, how it is getting tokenized, how it is getting batch processed. So everything you can see here. So this is just a heads up how this model works and what is the functionality. Thank you. Let's meet in the next video and we can see how we are going to deploy this.